Hey, what's up, guys? So, my name is Panchal Nayak, and I'm a third year in VIT. So today, this is the ninth video in the technique series, and today's topic is one of the trending topics for all the youth these days. Most of the people, even I have seen people from non-tech background who wants to transition their career from non-tech to data science. uh, so this today's topic is for those who want to become data scientists in future, or have some amount of curiosity to know about data science. So to begin with, uh, so uh, we will be covering the following areas like what is data science, who is a data scientist, what does data scientist do, and data scientist type, and why do we need them. And So, data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from data in various forms, both structured and unstructured, similar to data mining. Data science is the field of study that combines domain expertise, programming skills, knowledge of maths, and statistics to extract meaningful insights from data. And data science practitioners apply machine learning algorithms to numbers, text, images, video, audio, and require human intelligence. In turn, these systems generate insights that analysts and business users translate into tangible business value. So, you ca- this is as you can see in the diagram. It is clearly visible that data science is multidisciplinary. So, according to Byrne Jonathan, data science is applying data with science, and when it comes to data scientists, as the name suggests, these are the people who are mainly concerned with data, like who kind of work with data. But they are not only one who work with data. In the team, we have in the data team we have data scientists, data engineers, and data analysts. Data scientists will be able to take data science projects from end to end. They can help store large amounts of data, create predictive modeling processes, and present the findings. And while data engineers, uh, who are also known as data administrators and or data architects, they are versatile generalists who use computer science to help process large data sets. They typically focus on coding, cleaning up data sets, and implementing requests that come from data scientists. These typically, while data analysts, they typically help people from company understand specific queries with charts. So data analysts are also known as business analysts. So you might have come across the term several times. Like if you go to LinkedIn and all, various times you must have seen business analyst. So data analysts and business analysts are the same. They don't differ at all. So, if we talk about the skills that you require for data science, uh, for all three of them, you need to have a strong foundation in maths, which is most key things. When you if you want to become, it doesn't matter if you want to become a data scientist, data engineer, or data analyst. A strong foundation in maths is something which plays a key role, crucial role, in in your journey in becoming a data scientist or data engineer or data analyst or whatever you want to become. So this is the most key thing. And if you talk about the languages, then SQL, Python, and R is the language that you need to be thorough with. Apart from that, you also need to be very good with Tableau and Power BI. So, what do data scientists do? A typical data science process looks like this, which can be modified for specific use cases. Understanding the business, collect and explore the data, prepare and process the data, build and validate the models, deploy and monitor the performance. And next, if we talk regarding some of the other skills that you need to have, is you need to be inquisitive. So that is, you should be skeptical and curious. You should be always ready to explore new things. You should be very interested in knowing new things. That is something you need to have. Uh, you need to be very thorough with machine learning, statistics, and probability, as I told earlier. Scientific methods, like you need to be able to create hypotheses, you test them, and update understanding. And you need to be very good at coding, hacking, and general programming, which is very obvious when it comes to any software job. uh, then you need to know how to build data products and visualization to make data understandable to mere mortals. And then you need to have some domain knowledge. Like you need to understand the business and tell the relevant story from the business data. You need to be able to like tell the data summary to your employers, uh, not the employers, sorry, to your colleagues. You need to like able to tell the summary of the data by looking at the charts. So when it comes to data science, the first thing, the first word which you will come across when you start learning about data science is machine learning. So this is the first thing and the most basic thing which you need to learn first before you learn any of the other concepts in data science. So machine learning is basically deals with making models. So here you basically like try to train your model on a certain data set, and in future you try to give it some random data, and it will try to give the output for that data. It is very similar. You can compare it with a maths exam. If you are writing a maths exam, then during your preparation days you will practice a lot of problems. So if you practice a lot of problems in exam, if you get a similar question, you can solve it as well because you have practiced a lot of problems. So so basically there are four types of machine learning: supervised, unsupervised, reinforcement learning, and semi-supervised learning. So so we'll go across each one of them. So, first of all, if we talk about supervised machine learning, as the name suggests, supervised machine learning is based on supervision. It means in the supervised machine learning technique, we train the machines using the labeled dataset. Based on the based on the training, the machines predict the output. Here, the labeled dataset specifies the labeled data set is basically nothing but the dataset which contains the label. So what do you mean by label? So label here basically means the output of a particular set of input. For example, if you are doing heart disease prediction, let us consider a very basic example. Then in the heart disease data set, there are certain number of parameters, and at last you have the output. So that the final output column is known as the label. So in supervised machine learning model, we are training the model using labeled data. So after our model goes through training process, it will be able to predict like predict the output for any random data. So that's the like intuition behind supervised machine learning. So some of the basic examples, basic use cases where we use supervised machine learning include like dog and cat classification, and like heart disease prediction, as I said earlier. And in supervised machine learning, we will face two types of problems. Like two types of problems in the sense, using supervised machine learning algorithms, we can solve two types of problems, which is classification and regression. So classification means when you are trying to classify, or we can say, for example, let's consider we are solving dog versus cat. In that case, you are trying to identify whether a given being is a dog or a cat. In that case, super machine learning is really useful in like for these kind of problems. And when it comes to regression, regression basically deals with like when you want to predict something, like for example gold price prediction or beat hard disease prediction. So if we talk about the classification and regression, both are classified into some types. So we'll go through the types one by one. So in in classification, the some pop we have some of the there are several classification algorithms. Some popular classification algorithms include random forest algorithm, decision tree, logistic regression. The logistic regression is one of the most common algorithm which you'll be using in many problems. And like it's mostly useful it's mostly um, used in those kind of problems where you have the where the output can just have two values like yes or no, or maybe red or blue. In these cases, logistic regression is primarily used. And then we have support vector machine learning model. So in a lot of cases you'll be using support vector machine classifier. So for example uh, for example we have like for movie recommendation system, for these kind of movie recommendation system, we can go for support vector machine algorithm. And then uh, when we consider regression algorithms, the regression algorithms, some of the popular regression algorithms include simple linear regression algorithm, multivariate linear regression algorithm, decision tree algorithm, and lasso algorithm. So now let's talk about the advantages and disadvantages of supervised machine learning. Since supervised machine learning work with labeled datasets, so we can have exact idea about the classes of objects. And these algorithms are really helpful in predicting the output on the basis of prior experience. If it, when it comes to disadvantage, it has a couple of disadvantage. Uh, these algorithms are not able to solve complex tasks. It may predict the wrong output if the test data is different from the training data. It requires a lot of computational time, hence it is very time consuming. So like some of the common examples of supervised machine learning, as I said earlier, include like heart disease prediction, or mostly it is used in image segmentation or medical diagnosis, fraud detection, or maybe spam detection. Or whenever you face these kind of problems, like whenever you are facing a problem statement that belongs to one of these category, you can go for supervised machine learning without doubt. Next we come to unsupervised machine learning. So unsupervised machine learning is completely different from supervised machine learning. As the name suggests, in this case there is no supervision. That is, in this case, our model is trained using an unlabeled data. So the model predicts the output without any supervision. In unsupervised machine learning, the models are trained with the data that is neither classified nor labeled, and the model acts on the data without any supervision. So if we let's the main aim of the unsupervised machine learning algorithm is to group or categorize the unsorted data according to similarities, patterns, and differences. So so unsupervised machine learning is also having certain categories. So that includes clustering and association. So clustering means like uh, the clustering technique is used when we want to find the inherent groups from the data. It is a way to group the objects into clusters such that objects with the most similarities remain in one group and have fewer or no similarities with the um, objects of other group. An example of clustering example include customers by the purchasing behavior, which is one of the most famous problems in clustering, the customer segmentation problem. So, in customer segmentation problem, we basically go for k-means clustering algorithm. So the reason why we use k-means clustering, because it's a multi-class classification. In case of multi-class classification, when you are trying to identify like the group of customers who like you are able to, yeah, like you are trying to group the customers on the basis of like how frequently they are coming to the supermarket and how frequently they are purchasing. So for these kind of problems, we basically go for clustering. And in case of in case of customer segmentation, the best algorithm that we can go for is k-means clustering. If you can try, you can try with other algorithms as well. So the next type of problem is association. Association rule learning is an unsupervised learning technique which finds interesting relations among variables within a large data set. The main aim of this learning algorithm is to find the dependency of one data item on another data item and map. And the main aim of this learning is to find the dependency of one data item on another data item and map those variables accordingly so that it can generate maximum profit. The algorithm is mainly applied in market basket analysis, web usage mining, continuous production, etc. Some of the popular algorithms of associative learning, rule learning are a priori algorithm and ECLAT FP growth algorithm. So uh, then let's talk about the advantages and disadvantages of unsupervised machine learning algorithm. The main advantages of machine learning algorithm include these algorithms can be used for complicated tasks compared to supervised ones because these algorithms works on unlabeled data. Unsupervised machine learning algorithms are preferable for various tasks as getting unlabeled data set, which is easier as compared to labeled data set. The output of unsupervised machine learning algorithm can be less accurate as the dataset is not labeled. This is one of the major disadvantage of unsupervised machine learning algorithm. And moreover, working with unsupervised machine learning is more difficult as it works with unlabeled data that does not map with the output. So when we talk regarding unsupervised machine learning algorithm, is whenever you have problems falling in any one of the categories like network analysis or recommendation system, um, or anomaly detection or singular value decomposition. So in these cases you can go for unsupervised machine learning algorithms. So next we have semi-supervised machine learning algorithm. So semi-supervised machine learning is a type of machine learning algorithm that lies somewhere between supervised and unsupervised machine learning algorithm. It represents the intermediate ground between supervised and unsupervised learning. Although semi-supervised machine learning is the middle ground between supervised and unsupervised learning and operates on the data that consists of a few labels, it mostly consists of unlabeled data. And the main purpose of using semi-supervised machine learning is to overcome the drawbacks of supervised machine learning and unsupervised machine learning algorithm. The concept of semi-supervised learning is introduced for this purpose, so as to so we are able to overcome the drawbacks of supervised and unsupervised learning. So it's so the so if we talk regarding the advantages, so it is highly efficient, it is simple and easy to use, and um, and it is used to solve the drawbacks of supervised and unsupervised machine learning algorithms. When we talk about the disadvantages, the iteration results may not be stable. The accuracies can be very very low compared to supervised and unsupervised learning. The fourth and the final type of reinforcement of the fourth and final type of machine learning algorithm about which I want to discuss is reinforcement learning. So reinforcement learning works on feedback process. So in which we have a AI agent which automatically explores its surrounding by hitting and trailing and taking action, learning from experiences and improving its performance. So here the basic concept is that the agent who is responsible for doing this task get rewards for each good action and gets punishment for each bad action. Hence, the goal of reinforcement learning agent is to maximize the rewards. So you can compare it with a practical real life scenario. As students, whenever you are trying to whenever you are trying to study for exams, so each time you write your exam and then you get your results. If the results are good, you will feel motivated, and you will feel happy, and maybe your friends or your parents can give something to you. But if the result is bad, then you will feel bad. Your parents will feel bad. Maybe you will get scolded by your teacher, and next time, um, you will always have a mentality of maximizing your rewards or maximizing your marks so that there is a greater chance of getting rewards from your parents. So this is the basic intuition behind reinforcement learning. So it is very very similar to a human being, and due to its way of working, reinforcement learning is employed in various fields such as game theory, operation research, information theory, multi-agent systems, and many more. And uh, reinforcement learning can be formalized using Markov decision-making process. In MDP, the agent constantly interacts with the environment and perform actions. So we have certain categories of reinforcement learning. First one is positive reinforcement learning. So in positive reinforcement learning, it specifies the increasing the tendency that required behavior would occur again by adding something. It enhances the strength of the behavior of the agent and positively impacts it. Then, when it comes to negative reinforcement learning, the negative reinforcement learning works exactly opposite to positive reinforcement learning. It increases the tendency that specific behavior would occur again by avoiding the negative condition. Whereas for positive reinforcement learning, the positive reinforcement learning specifies increasing the tendency that the required behavior would occur again by adding something. So here we are not trying to avoid it, but rather it's like specifies increasing the tendency that the required behavior would occur again by adding something. So some real world use cases of reinforcement learning include video games, resource management, robotics, text mining. If you want, you can explore more about it in much detail. But for this video, we will keep till this point. And regarding the advantages and disadvantages, it helps in solving real world problems which are really, really complex. Uh, the learning model of reinforcement learning is pretty similar to human beings. Hence, the accuracy which the model produces is much better than the previous types of machine learning algorithms. Hence, it helps in achieving long term results. When we consider disadvantage, each and every algorithm has its own advantages and disadvantages. So even for reinforcement learning, which is the best machine learning algorithms out of these four, there are few disadvantages like reinforcement learning are not preferred for simple problems. Moreover, it requires huge data and computations. That's why they are not used for simple problems. And Yeah, so these are the types of the machine learning algorithms. So so now let us discuss about the various data science methods. So the various data science methods include sentimental analysis, time series analysis, data mining, Monte Carlo optimization, deep learning, multi-level modeling, machine data imputations, collaborating filtering, survival analysis, NLP, pattern recognition, classification and clustering, reinforcement learning, principal component and factor analysis, knowledge graph, proper propensity score matching, logistic multinomial and multiple linear regression techniques, forecasting and network analysis. Out of um, these days, every one of us have know about Chat GPT and other AI tools like Mid Journey, Chat GPT, Google Bard. So they all work on machine learning algorithms. So if you consider about Chat GPT, which is basically accepts data from the user, and it performs text processing, and according to the processing which it does, uh, according to the input which it receives from the user, after processing, if it gives certain, so it basically works on natural language processing. So most of the AI tools, like most of the AI tools which accept text data from the user, they they use natural language processing, because computer cannot understand text data. It converts the text data into numeric format, then it tries to process it, and then it produces the required output which the user wants. uh, and so when it let us talk about the various data science types. So it mainly consists of two things: data science for humans and data science for machines. So we will discuss about each type a bit later. Before that, I want to talk about deep learning. So even deep learning is another fundamental aspect of data science. So deep learning is when it comes to deep learning is not a type of machine learning, but I would say it is a improved version of machine learning. Uh, to be more clear, I would say that deep learning is nothing but a subfield of machine learning, and it's a branch of machine learning which is based on artificial neural networks. It is capable of learning complex pattern and relationships with data. In deep learning, we don't need to explicitly program everything. It has become increasingly popular in recent years due to the advantages in processing power and availability of large data sets. Since it is more efficient in working with complex data sets, therefore, as compared to machine learning, therefore, these days we go for deep learning rather than machine learning. So, as I told earlier, it is a subfield of machine learning that involves the use of neural networks to model and solve complex problems. The neural networks are modeled after the structure and function of the human brain, and consist of layers of interconnected nodes that process and transform data. The key characteristic of deep learning is the use of deep neural networks, which have multiple layers of interconnected nodes. These networks can learn complex representations of data by discovering hierarchical patterns and features in the data. Deep learning algorithms can automatically learn and improve from data without the need for manual feature engineering. So, deep learning has achieved significant success in various fields, including image recognition, natural language processing, speech recognition, recommendation systems. Some of the most popular deep learning architectures include ANN, artificial neural network, CNN, convolutional neural network, and RNN, which is recurrent neural network. So I will just give a brief idea about each one of them. So, artificial neural network is a kind of deep learning that contain artificial neurons, which are also known as units. These units are arranged in a series of layers that together constitute the whole artificial neural network in a system. A layer can have dozen units or even million units of these neurons, as this depends on how complex neural network will be required to learn the hidden pattern in the dataset and solve the problem. Commonly, like in, in more general terms, uh, artificial neural network has an input layer, an output layer, as well as an hidden layer. The input layer receives data from the outside world, which the neural network needs to analyze or learn about. Then this data passes through one or multiple hidden layers that transforms the input into data that is valuable for output layer. Finally, the output layer provides an output in the form of an response of artificial neural networks to input data provided. So the next type of conventional neural network uh, next type of neural net the next type is convolutional neural network. So convolutional neural network is a type of deep learning neural network architecture which is commonly used in computer vision. So computer vision is nothing but a field of artificial intelligence which basically enables a computer to understand and interpret the image or visual data, or it also includes video and audios. So when it comes to machine learning, artificial neural network performs really well. But neural networks are used in various data sets like image, audio, and text. So different type of neural networks are used for different purposes. So the data is fed into the model, and the output from each layer is obtained from the above step. This is called feed forward. We then calculate the error using an error function. Some common error functions are cross entropy, square loss error, etc. Error functions measures how well the network is performing. After that, we back propagate into the model to calculate the derivatives. This step is called back propagation, which is basically done to minimize the loss. So here we basically have several layers of hidden. We basically have several layers of neurons, which basically which are basically training on data. The first time when it generates an output and it compares it with the predicted output, the output is not it then finds the loss using the loss function. So first time the loss may be somewhat higher, so it will again back propagate. In this back propagation, what will happen is like each neuron has a certain weight associated with it. So during back propagation, the weights will get updated. This will happen in such a manner. Uh, this will happen in such a manner again after this after the updation of weight, again forward propagation will take place. This cycle will continue. This will happen in such a manner so that the loss which you are obtaining, or the difference between the predicted output and the output which we got from the model, is minimum. So this cycle of back propagation and forward propagation is basically done to minimize the loss. And the next type about which I want to discuss is recurrent neural networks. So recurrent neural networks is basically used for time series analysis. So whenever you have problems which are related to time series analysis, the examples of which you will if you want to uh, see the examples of time series analysis, you can search about it in internet. So basically, to handle a certain type of data, one of the most difficult types of data to handle and forecast is the sequential data. Sequential data is different from other types of data in the sense, while all the features of a typical data set can can be assumed to be order independent. This cannot be assumed to be this cannot be assumed for sequential data set. To handle such type of data, the concept of recurrent neural networks were conceived. It is different from artificial neural networks in a structure. So while other networks travel in a linear direction during the feed-forward process or the back propagation process, the recurrent neural network follows a recurrence relation instead of a feed-forward and uses back propagation through time to learn. So, like types of uh, these are the basic things in deep learning about which I wanted to discuss. So, after discussing about machine learning and deep learning, another key thing uh, which the students should be knowing about is nothing but AI. So so AI is when it comes to data science, the key things which one needs to be thorough with in data science includes artificial intelligence, machine learning, and deep learning. So discussing artificial intelligence in detail would be out of the scope of this course. Here I would just give a brief introduction about artificial intelligence. But if you want to learn more about it, you can go ahead and explore about it as much as you can. So basically, artificial intelligence refers to the simulation of human intelligence in machine that are programmed to think and act like humans. It involves the development of algorithms and computer programs that can perform tasks that typically require human intelligence, such as visual perception, speech recognition, decision making, and language transition. So this is a um. So basically, what do you if we try to understand the meaning of artificial intelligence? It base if consider the word intelligence, it basically refers to the ability to learn and solve problems. But here, it does not refer to human intelligence. Rather, it is it is it is the like it is we are trying to make models and we are trying to make computers intelligent so that they can act intelligently. So this is the basic idea regarding artificial intelligence. So the next thing about which I wanted to talk about is the data science types. So first, let's talk about data science for humans. So, as I told earlier, data science type consists of two types. One is data science for humans and data science for machines. So first, let's discuss about data science for humans. Data science for humans, the consumers of output are decision makers like executives, product managers, designers, or clinicians. They want to draw conclusions from data in order to make decisions such as which content to license, which sales lead to follow, which medicines is less likely to cause an allergic reaction, which web page design will lead to more engagement or more purchases, or which marketing email which will yield higher revenue, or which specific part of a product user experience is suboptimal or needs attention with. So next, um, next type about which I want to discuss is data science for machines. So here the consumers of output are computers, unlike data science for humans, where the consumers are of the output are decision makers, like executive, product managers, designers, or clinicians. The examples of work products of these data scientists are recommendation systems, which recommend what shirt a customer might like or what medicine a physician should consider prescribing based on a design optimization function, such as optimizing for customer clicks or for minimizing readmission rates to hospital. So these are the things that are included in data science for machines. So now let's talk about the importance of data science. So why data science is important? So the this the data science is very important, and the main reason behind the importance of data science is every business has data, but its business value depends on how much they know about the data they have, how much information they are able to gather from the data, how much they are, how much, to what extent they are able to analyze the data. That actually decides the success of the company, or the profit of the company. Data science has gained importance in recent time because it can help businesses to increase the business value of its available data, which in turn can help them to take competitive advantage against competitors. It can help us to know our customers better. It can help us to optimize our processes. It can help us take better decisions. Because of data science, data has become a strategic asset these days. So, as I told you earlier, if you want to learn data science, you need to have a thorough foundation in maths, es- especially statistics. Like even when you are learning machine learning and deep learning, there you will come across several points where you will feel uh, that the foundations that having a strong foundation in statistics, uh, as well as statistics as well as linear algebra. um I would also like to add linear algebra. So having a strong foundation in these two can really help you in understanding machine learning and deep learning. So yeah, that's it for today. Hope you like my video. So if you have any questions, you can type it down in the comment section.